Let's hey db shell as su again and run the ps-hey z command. PS is the process status command line application. The hey flag tells PS to print all the processes. The z flag adds a security label column to each process. The security label is also known as the security context. The next column is the user, which the process is running as. Next are the process ID and parent process ID. A child process is created when a process decides to fork itself to a new process. A new process can also be created when a parent process executes a shell script or a binary application. We can see that all the Java applications have the same PPID. Scrolling up can tell us it is the Zygote process, which is the C++ native executable that starts the Java virtual machine. Zygote runs as root user with the Zygote security label. Zygote, like many other native processes, have one as the PPID. One is for the init process, which is the process that boots the Android OS. The init process also runs as root user but with the init security label. The init process is started directly by the kernel, which has 0 as PID. VSZ is the virtual memory size. The virtual memory has addresses allocated in the process's memory map, but these pages might not occupy any physical memory. RSS is the resident set size. The RSS accounts only for memory that is currently occupying space in the device's physical memory. Since part of the memory is shared, many processes may use it. Adding up all of the RSS values can end up with more space than the system actually has. WChan is the wait location in the kernel, which can be useful to debug long waits. The next column is the instruction pointer address, which seems to always be 0. The next column is the process state. R is for running, S is for sleeping, and I is for idle. Let's see how apps are sandboxed by the user IDs. The settings process runs as a system user and has a security label of a system app. The Gallery 3D app runs as U0 Hey 110 user, which is a kernel UID of 10,110. The Gallery 3D app has a security label of an untrusted app. There are other untrusted apps, but these do not have the same UIDs. We can actually see that every app is installed and runs as a unique user. The Dialer app runs as U0 Hey 101 user with a private app security label. Let's navigate to the data folder and list its content. The data folder in the data partition is used by different apps to access their private files. For example, the Dialer app would store its databases in that folder. It might save a non-encrypted Dialer DB file. But rest assured, these files are still sandboxed by the DAC, as it only allows the Dialer UID to access that folder. Keep in mind that because we run as root, we got full access to any folder or file.